get a sense of the data, even if you don't have a lot of like pre-knowledge in the field. And for example, for Bioscan browser, I quickly showed the search feature. Like for example, we have integrated with the INAT common names, so you can like even if you don't know the scientific names, you can still like browse the records.
Luca.
For those that are not experienced working with events, what is your technical knowledge?
Yeah, I understand, and I think like as I said, I think it's worth having a look at existing tools and if you can like align your data with existing standards, like the opportunities to find existing tools that could highlight or that could visualize your data will be better, I think. But also like I think you can, if you have like some programming skills, I think you can come also with these new Gen AI code assistant tools come like a pretty long way.
Thank you. We're out of time for questions. There were some more questions in the audience, so I'm sure they'll find you during the break.
Yes.
Thank you, Anna.
Thank you.
So we have Peter.
Thanks. Hello, everyone. My name is Peter. I am here for the LEPMON project, and I'm the guy with the programming skills. Thanks for introducing me, Anna. So I try the presentation not to be that technical. First, a short introduction on the LEPMON project. In the LEPMON project, we are developing a highly standardized system for monitoring nocturnal insects. We are testing it across a wide range of habitats. You see some images here, along urbanization gradients and at different vertical levels, including the canopy. We are also testing the devices under tropical conditions and contributing to monitoring standards like the last days. To achieve this, we developed a device that is at the core of the project. It is being developed at the University of Jena with Dennis. We have one representative here, in collaboration with external partners. So think of my presentation companion here. It's about this height, yeah, the Ani trap, automated recorder of nocturnal insects that stands on 3 adjustable legs, so to say. The camera is located in here. It's a 12 megapixel camera. It's with an industrial standard, so it has some features, so to say. The housing is waterproof. We heard it 2 presentations ago, so this is quite important. We have equipped the whole system with environmental sensors for humidity, environmental light, and temperature. The screen, so the acting stage for our moss, has a size of a little bit more than A4. And on top of that, so here, or here, is the attractor, the UV light that shines the whole night. And the distance from the screen to the camera is fixed, 70 centimeters. That allows for size calculations. So let's try this one. This film is composed of 300 images captured over the course of one night using an Ani in Leipzig. The recording begins at 9:02 p.m., half an hour before sunset, and ends after 5:23 a.m., half an hour after sunrise. The light source is LEPI LED was turned off 1 hour before sunrise to give the moths a chance to fly away. Above, you see the core metadata we record, so a unique ID consisting of the device ID, a code for the locality, and the timestamp, of course. Yeah, recording time, and so on and so forth. What you might have seen is the highest activity was around 10 p.m. till 2 p.m. and afterwards the amount of moss on the screen vanished. What makes the LEPMON project special is that we use the same methodology to observe moss across Germany. Here's an overview of what's happening at 9 different locations at 12:31 a.m. on July 29th last year. This shows that the same setup can generate comparable data across sites. The LEPMON project runs for 3 years from 25 to 27. 8 cities across Germany, each of which proposed 5 ANIs, are selected in our so-called urban gradient program. The ANIs are distributed along a gradient of impervious surface cover, ranging from densely built up inner city areas to near natural sites on the outskirts. This year, we launched approximately 80 lightweight ANIs, so-called citizen science ANIs. Anyone interested can obtain an ANI and set it up at a location of their choice. So the red dots are the urban gradient program. The yellow dots are the Habitat Pro program. So this wide range of habitats we are observing, they are not bound to the citizen urban gradient program. So numbers from our first season. So it's a technological development project. We thought of starting in April last year. Yeah, with the beginning of the season. The first devices were set up in April, and the real recording started in June with a few traps, but we recorded over 1 million images from over 4,800 nightly runs from our 46 devices in the fields. Overall, we detected 2.2 million objects on the different images, resulting in 987,000 unique specimens, and so far 800,053 AI predictions. We do a recording every 2 minutes for every device. These numbers clearly show that manual processing alone is not feasible. You all know that, of course. This is where AI becomes essential. This is why a major work package in our project is the further development of AI models for moss monitoring in Germany. So we come to the core of the presentation, the LEPMON annotation and upload tool. This is the central gateway to the LEPMON workflow. I haven't put a screenshot in it because doing screenshots on software development is kind of boring. So please visit the QR code, but please don't be disappointed. It's a register page only. You need to be registered because it's a development project to become access. But we are on to publishing the stuff. So the portal, it is the portal through which users upload images from ANI devices, manage projects, and uploads and search and explore and download data. At the same time, LEPMON starts the AI-based localization, so after uploading and classification steps, and provides tools for manual annotation, taxonomic identification, and expert confirmation. The data are organized in a simple hierarchy. So we have projects, including the ANI devices. Each device produces multiple runs, so over the different nights, and each run contains all images from one recording site. The data flow you see here is certainly not significantly different from that of other monitoring projects. The images generated by ANI are uploaded by the user to LAUP, and the animals are automatically located by the ANI. So this is the first step here. Groups of images containing the same individual are then combined into a track and classified by the ANI or processed in parallel by citizen scientists. The results are validated or corrected by experts. Right, most thing. The validated data are then available for subsequent analysts. This is where Rolk van Klink comes in, who does mainly this part. Please watch his presentation tomorrow. So some insights. This second step, the localization, is done AI-based, but also this is thought to be a film, but unfortunately PowerPoint is not willing to show that. But you all know that the AI makes mistakes or oversees something. So this is an example image, and users can correct bounding boxes or draw new ones or remove erroneous one. So in the first models, the screws you see here, to fix the 3, were also detected. Kind of annoying. So species identity, so to overcome this overwhelming amount of images, the species identification by the AI requires a necessary preliminary step. All bounding boxes of an individual across multiple images are grouped into a so-called track. We have discussed that thoroughly 2 days ago. The AI then classifies the first image in this track. There are other approaches, but we use the first image here because we do the tracking on a mathematical model, not using the AI. Animals within the bounding box can be identified directly by either citizen scientists on a higher taxonomic level, of course, because they are not that trained, or by experts in the annotation tool. Existing predictions are validated by experts, let's say. Our data catalog helps with that. This is somehow similar with what Anna showed before. So we have an indexed data catalog on all the content we have in our database, in our LEPMON database, and it's possible to search, filter, facet the images, and the results, show that later, provide direct links to the annotation and localization tool. All results can be downloaded as CSV. Here's an example of filtering using an ANI and the Noctuididae family. Don't see it. The results are filtered by the localized animals. Clicking on an image takes the user directly to the annotation tool where the identification can be confirmed or corrected. So the expert can browse here for the groups of interest on a family level, on a genus level, and go directly to the annotation tool. This is thought to be a film again, but Microsoft is unwilling to show it. I've made a film to show the interaction because doing that lively is also a risk. Anyway, so you have here the so-called annotation tool that allows for confirming what has been identified by the AI. I'm logged in as a citizen scientist, so I don't see AI predictions here. This wouldn't help and it wouldn't be of any help. Expert would see previous identifications, so he or she can confirm that. You remember the screw issue here, so we have also above this no animal thing, so people can mark that here. You can give a rating on the quality of the image below, rotate it, adjust brightness and contrast, and of course, save what you've done here. The code for the whole LEPMON stack is openly available on our GitLab server since 5 days. Take-home messages. So the LEPMON project establishes a scalable and end-to-end infrastructure for the long-term monitoring of nocturnal insects. with a particular focus on Lepidoptera, of course. Our newly developed methods allow us to collect data on insect diversity at an unprecedented level of detail and accuracy, hopefully. A key innovation of the Cloud Portal lies in the close coupling of data management with online annotation and identification workflows. LEPMON covers the entire data cycle from hardware development to analysis-ready data for research and conservation. Thank you for listening.
Perhaps you could share those videos in the Slack channel so people can
That's a
see
good
them.
idea.
That would be nice.
Once I manage to log in.
Yeah. We have time for one quick question.
Might be a dark question.